Today we will learn the remaining problems from exercise 3.2 C. The fifth problem is evaluate integral of 7x plus 3 upon root 3 plus 2x minus x square dx. So let I be the given integral. Then we will express this numerator 7x plus 3 as a times derivative of the denominator plus b. That is 7x plus 3 is equal to a into 2 minus 2x plus b. This is our equation number 1. Now multiply this bracket by this a. You get 2a minus 2ax plus b. So equating the like terms on both the sides, we get minus 2a is equal to 7 and 2a plus b is equal to 3. After simplifying, you get the value of a as minus 7 by 2 and b is equal to 10. Use these values in equation number 1. We get 7x plus 3 is equal to minus 7 by 2 times 2 minus 2x plus 10. Use this numerator in our given integral. Then divide this numerator separately by this denominator. You will get two separate integrals. Let us call the first integral as I1 and the second integral as I2. Okay. So where the first integral is I1 and the second integral is I2. Now let us consider the first integral. Here it looks like f dash of x upon root f of x. So its integral is 2 root f of x plus c. You can use this formula or you can put 3 plus 2x minus x square is equal to t to evaluate this integral. Using this formula, I will get the integral I1 is equal to 2 root 3 plus 2x minus x square plus c1. Now let us consider the second integral I2. 1 upon root 3 plus 2x minus x square. Here we have to complete the square. Before that, 3 minus, we will take a minus from these two terms common. Then my x square minus 2x. Now the last term is 1 upon 2 into minus 2 bracket square. So minus 1 bracket square is plus 1. So add and subtract plus 1. 3 plus 1 minus x square minus 2x plus 1. This term, this bracket is x minus 1 bracket square and this is 2 square. So the given integral is in the form of 1 upon root a square minus x square and its integral is given by 1 upon sine inverse of x by a. So the given integral is I2 sine inverse of x minus 1 upon 2 plus c2. So the from equation 1, 2 and 3, 4, we can write minus 7 by 2 times 2 root 2, 2 root 3 plus 2x minus x square plus 10 times sine inverse of x minus 1 upon 2 plus c, where this c is minus 7 by 2 c1 plus 10 times c2. Because whenever we are going to add these integrals, the first integral is contains c1 and the second integral contains c2, and we are multiplying the integrals by minus 7 by 2 and 10. So minus 7 by 2 c1 plus 10 c2. So this is the integral. Final answer minus 7 root 3 plus 2x minus x square plus 10 sine inverse of x minus 1 upon 2 plus c. Now the next example is root x minus 7 upon root x minus 9. We can write it in 1 square root. Then we will multiply it by x minus 7 upon x minus 7. So in numerator you get x minus 7 bracket square and in denominator we get the two factors. Take their multiplication, you will get integral of x minus 7 upon root x square minus 16x plus 63. So here again we will express the numerator as a times derivative of the denominator plus b. So after simplifying you will get the value of a as 1 upon 2 and the value of b is equal to 1. So put that value in equation number 1. We will get x minus 7 as 1 upon 2 times 2x minus 16 plus 1. So our integral becomes, so these are the two integrals. Delete, this is I1 and this is our I2. So 1 upon 2 times I1 plus I2, where I1 is the first integral and I2 is the second integral. Now we will solve these integrals one by one. I1 is equal to integral of 2x minus 16 upon root x square minus 16x plus 63. Okay, so here you can use the formula f dash of x upon f of x, root f of x is 2 root f of x plus c, or you may use the substitution method to solve this example, because x square minus 16x plus 63 is equal to t, then its derivative 2x minus 16 is already present in the numerator. So the integral of the first integral is 2 root x square minus 16x plus 63 plus c1. Now we will go to the second integral, 1 upon root x square minus 16x plus 63. So the last term is 1 upon 2 times minus 16 bracket square. So 8 bracket square is 64. So 64 minus 1 is 63. This term will gives you x minus 8 bracket square, and this minus 1 is 1 square. So the integral becomes 1 upon root x square minus a square is log of x minus 8 plus root x minus 8 bracket square minus 1 square plus c2. So the integral of the given function is log of x minus 8 plus root x minus 8 bracket square plus minus 1 square plus c2. So if we can simplify this x minus 8 bracket square minus 1, it is x square minus 16x plus 63. Now you use these integrals in our previous one formula, you get 1 upon 2 times 2 root x square minus 16x plus 63 plus log of modulus of x minus 8 plus root x square minus 16x plus 63 plus c. Evaluate integral of root 9 minus x upon root x dx. Write it in one square root only, then multiply divided by 9 minus x. You will come to the integration of 9 minus x upon root 9x minus x square. Now you can write this numerator 9 minus x is in the denominator as a times d by dx of 9x minus x square plus b. So equating the like terms from both the sides, you get a is equal to 1 upon 2, and put that a is equal to 1 upon 2 in this second equation, you will get b is equal to 9 upon 2. So I can write this 9 minus x as 1 upon 2 times 9 minus 2x plus 9 by 2, and 1 upon 2 9 minus x 9 minus 2x plus 9 by 2, which is therefore I is equal to 1 upon 2 times 9 minus 2x upon root 9x minus x square plus integral of 1 upon 9x minus x square. Let us call this first integral as I1 and the second integral as I2. So 1 upon 2 times, where I1 is equal to integration of 9 minus 2x upon root 9x minus x square dx, and I2 is equal to integration of 1 upon 9x minus x square dx. So let us take I1 9 minus 2x upon 9 minus so I1 is equal to integration of 9 minus 2x upon root 9x minus x square. So it is in the form of f dash of x upon root f of x. So its integral is 2 root f of x plus c. So I1 is equal to 2 root 9x minus x square plus c1. Now take the second integral and make the complete square in the denominator by adding and subtracting 81 upon 4. That is the 1/2 coefficient of x bracket square. So we get I2 as integral of 1 upon root 9 by 2 bracket square minus x minus 9 by 2 bracket square. So it is in the form of 1 upon root a square minus x square, and its integral is given by sine inverse of x by a. So use that formula and just simplify it. We'll get I2 as sine inverse of 2x minus 9 upon 9 plus c2. use all those integrals in our equation to hold it integral 1 upon 2 times 2 root 9x minus x square plus 9 by 2 times tan inverse of 2x minus 9 upon 9 plus c, where c is 1 upon 2 times c1 plus 9 by 2 times c2. So this 2 will cancel and you get root 9x minus x square plus 9 by 2 times sine inverse of 2x minus 9 upon 9 plus c. This is the integral of the given function. Now the next problem is 3 cos 3x upon 4 sine square x plus 4 sin x minus 1. Now here you have to use the substitution sin x is equal to t. After the substitution, the given problem will reduce to our standard type. Then cos x dx is dt. So I is equal to integral of 3 upon 40 square plus 40 minus 1. We can take 1 upon 4 common, and 3 is also integral outside the integral. 3 upon 4 times 1 upon t square plus t minus 1 by 4. So here the last term we will get is 1 upon 2 into coefficient of t is 1. So 1 upon 2 into 1 is 1 upon 2 and its square is 1 upon 4. So add 1 upon 4 minus 1 upon 4. So first three terms will give you t plus 1 upon 2 bracket square, and these two terms will give you 1 upon root 2 bracket square. So this is in the form of 1 upon x square minus a square, and its integral is given by 1 upon 2a log of x minus a upon x plus a. So use that formula and just go on simplifying. You will get the integral of the given function. So what is t? T is 3 upon 4 root 2 log of 2 sin x plus 1 minus root 2 upon 2 sin x plus 1 minus 2 plus c. Now the next example is root of e raised to 3x minus e raised to 2x upon root e raised to x plus 1 dx. Clearly, you can take e raised to 2x common from the numerator, e raised to 2x common from the numerator. Then what you will get, the e raised to 2x can be written as e raised to x bracket square using laws of indices. So we can take it outside the square root. We're going to get e raised to x dx. Now, in square root, use the substitution e raised to x is equal to t, so that you get t minus 1 upon t plus 1 dt. Then multiply and divide by t minus 1. So you get the integral as t minus 1 upon root t square minus 1 square. Now separately divide. These are the two integrals. You can say that I1 and I2, but I am directly solve these examples, because the derivative of this t square minus 1 is 2t. Here is only the problem is of 2. So what I will do, I will adjust the 2 by multiply divided by 2. So we will get this term. So now it is in the form of f dash of x upon f root f of x. So its derivative integral is 2 root f of x. And here is the standard formula 1 upon root x square minus a square. It is log of x plus root x square minus 1. Here 2 will get cancelled and you get root t square minus 1 log of t plus root t square minus 1 plus c. So back substitute our the value of t as e raised to x. So e raised to x bracket square, e raised to 2x, e raised to x, e raised to x bracket square, e raised to 2x. This is the solution of the given problem, and this is all about the exercise 3.2 C. Now we will stop here.